Hi everyone, I'm Jeff. In this next problem, our goal is to write an expression for the nth term in the sequence, 2 over 2, minus 3 over 4, 4 over 8, and minus 5 over 16, etc., where n is the positive integer values, 1, 2, 3, 4, and so on. So to start, we look at our sequence and try to identify a pattern. One that jumps out right away is the numerator increasing by 1 each time, 2, 3, 4, 5, and so on. Now, a way we can represent this in terms of n is to say n plus 1. Remembering that n is the numbers counting starting at 1. We can see 1 plus 1 is 2. 2 plus 1 would give us 3. 3 plus 1 would give us 4, and so on. The next thing we notice is that each term has the opposite sign as the term in front of it, starting with positive, then negative, positive, negative, and so on. Now, how we can represent this in terms of n is to say minus 1 raised to the n plus 1 power. What does this mean? Well, when n is equal to 1, we get negative 1 raised to the 1 plus 1 power. Now, negative 1 raised to the 1 plus 1 power is the same as negative 1 squared, which of course is minus 1 times minus 1, or positive 1. So what's cool about this is then when n equals 2, we get minus 1 raised to the 2 plus 1 power, where n is 2. In other words, this is minus 1 to the third power, or minus 1 times minus 1 times minus 1. Again, these are positive, so that cancels out, which leaves us with negative 1. This means that every other term is going to be the opposite as the one before it, so we're almost there. The final step is to include the denominator, which is going 2, 4, 8, and 16. In other words, it's increasing by powers of 2, which would be represented by 2 to the n. Once we combine all of these, we'll see that our expression can be written minus 1 to the n plus 1. That'll give us our sign switching. N plus 1, which will give us 2, 3, 4, 5. And then the denominator, 2 to the n power, which will give us 2 to the 1 is 2, 2 to the 2 is 4, 2 raised to the third power is 8, and so on. So this would give us the answer to this problem.